So in this slide, we talk about subsets of sets. So we will describe this pictorially also. So let us start with the definition. Now if every element of a set A is also an element of set B, so let us write this down. So what we are trying to describe is when A is a subset of B. Now if every element of a set A is also an element of set B, then A is a subset of B. So you write this as A subset of B. So let us show this pictorially. So this picture is called Venn diagram. This will be clear in the next slide. But you can see as a picture, B contains this subset A. So let us talk about some examples. So example 1. So set of all women is a subset of all people. So subset of all people is a smaller set of women. So that is clear. Set of women is set A, B is set of all people. Another example, set 2, 4 is a subset of set 1, 2, 3, 4. Now a set is a subset of itself. So 1, 2, 3, 4 is a subset of itself. That is 1, 2, 3, 4. So null set belongs to every set because it is set without any elements. So null set is subset of every set. Now this point number 4 is important. A null set is subset of every set. So null set is like this O with the slash sign in between. Yeah, O with the slash sign. Okay, number 5. Every set is a subset of itself. Yeah, every set is a subset of itself. So this we have already shown in example 3 also above. But let us write this down. Every set is a subset of itself. So there are more examples. So natural numbers are subsets of integers, which are subsets of rational numbers, which are subset of real numbers. Now we have not talked about real numbers before, but they are nothing but rational numbers plus numbers like root 2, root 3, pi, root 12, root 15 and so on. So what are real numbers? It is rational numbers, and you adjoin it with irrational numbers like root 2, pi, root 5, root 3, and so on. So natural numbers you already know. This is nothing but 1, 2, 3, 4, 5. Integers you already know, minus 1, minus 2 all the way to minus infinity, then 0, 1, 2 all the way to infinity. And rational numbers you know of the form a by b. Yeah, we have already talked about rational numbers in previous slide. So now I want to talk about real number line. So real number line is nothing but you have a number line which you have been drawing all the time in high school. So it is just a line with numbers on it. Yeah. So it is just what we draw in high school or in lower classes as x-axis or the y-axis. So for example, x-axis in a graph is a real number line. Y-axis is also a real number line. So just like x-axis, it has a 0, it has 1, it has 2, and it has minus 1, it has minus 2. So let us write down what I have just said. So 0, 1, 2, 3, and then you have minus 1, minus 2, minus 3, and so on. Yeah. So the closed interval closed intervals like are of the form like you write square brackets 1 comma 2 or square brackets root 2 comma 2. What does this closed interval mean? What I have written in square brackets. So we will explain this now. So you have starting point A and ending point B. So obviously A has to be less than B, just like 1 is less than 2 and root 2 is less than 2 in the examples above mentioned. So this closed interval is of the form like this. It is x such that x lies between A and B, but x can take value of A and x can take value of B. Now open interval. Now open interval is written by round brackets. So rather than square brackets, you have round brackets. And it looks precisely like the above, except that x lies between interval, x lies between A and B, or on the interval from A to B, but x does not take value of A or B. So it just lies between them. For example, 1, 2, x lies between 1 and 2, but x cannot be 1 and x cannot be 2. Similarly, x could lie between 3 by 4 and root 5, but x cannot be 3 by 4 or root 5. In the closed interval, it can take the endpoint values, but here it cannot. Now we talk about half open intervals. So here again it is precisely like the above, but now x can take the value of A but not the value of B, and it can take all the values between A and B. Similarly, we have another form where x again lies between A and B, but x cannot take the value of A, but it can take the value of B. So this is just trying to understand, this is just terminology. You're just talking about lying between two endpoints. The two endpoints are A and B. Now let us draw them. Now I've started drawing it for the closed interval. So notice that the A and B both values, it takes, x takes all the values between a and b, and that's what I have highlighted. Again, for the open interval, x just takes value between a and b, so it does not take the value of endpoints. So there is a hole at both a and b. Yeah, I will make this hole at b more clear later on. Yeah, so you should see that there is a hole at a and hole at b. Yeah, it takes all the values between a and b, but does not take value of a and b. In half open, in the first case, where you have square bracket on the side of a, so x takes the value of a, but it does not take the value of b. So there is a hole at b. Yeah, there is a hole at b, so it does not take the value of b here. So you see, side of b is round bracket, on the side of a there is a square bracket. And now the last case, here there is a hole at a, because on the side of a there is a round bracket, so x does not take the value of a. So yeah, I'm just putting a hole at there also, the open interval. So x does not take the value of a, so there is a hole at a and there is no hole at b, because x can take the value of b. Yeah, there is a square bracket at b, and that is the construction. It takes all the values between a and b. So on this slide we talked about subsets and real number line.